Welcome to the Modern Application Development Screencast. In this short screencast, we will learn how to test our Flask app using Pytest framework. Before we start, open the following applications on your Ubuntu desktop so that you can work along with me. Browser, preferably Firefox, Chrome or Brave is fine too. Gedit text editor or any other IDE. I'm going to use Sublime Text. A terminal, built-in one in Ubuntu is fine. Make sure you have a copy of the project that we had used until now so that we can continue working on the same project without wasting much of time. Right. You would have already seen unit testing in your Python class. Unit testing checks small component in your application, most probably a function. So it actually checks the functionality of a smallest function. Integration test usually checks the integration between one or two components within your application. Similarly, functional testing tests the functionality of the application. Since we are working with Flask, we'll mostly concentrate on testing Flask applications, which is going to be either integration or functional testing. To do our testing, we are going to use a framework called Pytest. We could have used built-in unit tests, but Pytest offers a lot of functionalities that's going to be useful to test Flask app. So we're going to use Pytest. Let's start with our application and enable the environment. I'm already in the same folder path. You can see here. I'm just going to clear it. Now I'm going to enable the virtual environment. Okay. I've enabled the virtual environment. So now I'm going to install the Pytest, which is simple. Okay, shouldn't take much time. It's installed. I'm also going to install another package called coverage. I'll let you know what it's used for once we reach that part of the tutorial. So I've installed that. And then I'll install another package called Beautiful Soup. If it's already installed, it may not install it again. That's fine too. So you could add the same thing into your requirements.txt and run it too. It's actually beneficial if you add them to the requirements.txt and run it together, right? These are already installed, so I think reinstalling them doesn't make any sense. Okay. So now we are done. So to start with, we actually create a folder called tests within the same folder structure in parallel to application, right? Because we want to test everything within the application module. So I'm going to create a new folder called tests, right? And since it's going to use it like a package, so we have to create an init file under it, right? Okay, so we have within that we can create a folder structure for unit tests and folder structure for like functional tests. Let's create one just as an example. Unit TSTS, and since it's a package, I'm going to create init file under it too. Similarly, I'm going to create a package called functional. Okay. And similarly, I'm going to create a file under it. Okay. Now the way Pytest works is if you give it a folder called tests, it actually tries to find all the files that start with test underscore and considers them as test files and tries to run them. So let's create the first test file, just an example inside the unit test called test underscore example. Okay. .py. for an example, as an example, I'm going to create a dummy function here and try to test that. Okay, I'm going to create the function also in the same, in the same file. All right, def, let's say add x comma y. Return addition of it, x plus y. Okay, now I want to test it. Usually in Pytest you usually start all test functions with starting with test. So let's say def test add, right? This is the function that's going to test the add. I'm going to call z is equal to add, x is 1, let's say y is 2, so z should be 3 on correct thing. So I'm going to assert assert z equal to 3, right? This is my assertion. Now I have a function. It could have been anywhere. We could import it if it was in the main classes somewhere within the application. We could have imported it. We'll see how to do it. But as an example here, I've defined the function here itself, and I've added the test case here itself. Assertion actually checks, whether the values are correct or the end result is correct. Right? Now we have to run this. To run this, actually, I'm going to create a simple function just like our local run. I'm just going to create another function called local testing, right? Script called local testing, just to make it easy. Dot sh, right? Now we'll see what is we are going to put into local testing. I'm going to just copy this local run. So this one all will remain same. We are now going to run the main function. We're going to run Pytest. Before we do, we want to set environment to testing, right? Because we are in the testing environment. Now I'm going to put call to Pytest. Just Pytest should be enough, because it would look through all the folders, subfolders, everything for testing files, test files. It start with test underscore, and it should be able to run. Just to give verbose output, I'll add a verbose as the input parameter. Also send disable warnings as a parameter, because I don't want to see any warnings. I just want to see errors or failed cases. Now we can actually run this. Let's see what happens if we run this. Right, we are here. We have already enabled the virtual environment, so it should be fine. So I will run sh local testing. Right, so now it says it has collected one item. It is able to run one test. Inside test, I've got test py, and it ran test underscore add, and it has passed. Now if let's say we had a problem, let's say instead of we made a logical error, we called the function as add, but we are actually subtracting it. Then when I run this, it's telling me that assert -1 is equal to 3 is failing. It should have been actually -1, and hence the assertion failed and the test case is failed. So this is how we actually run the Pytest. It's quite simple and straightforward, isn't it? Now we want to test our Flask app. To start test our Flask app, we want to actually send a request to our Flask app and get the response back and test it. One way is actually to start Python main.py and connect to it at whatever port, localhost 8000, send a request, get the response and do it. There's another way to do it, which is Flask way of doing it. That is, Flask gives you a client which helps you to actually send the request to the Flask app and get the responses. Here you can see Flask provides a way to test your application by exposing a test client. handling the context locals for you, so that you can just directly call the endpoint using this client and then get the response instead of setting requests and using it. Let's try one. Okay, within our since it's going to be end to end, we are going to call the client, it's going to connect all the way and respond back. It's going to be within the functional test. Now let's say we are going to do within functional test, and I'm just going to call test example, right? I'm just going to write an example one to start with, right? Let's do that. I'll create a new file. I'm going to set it as test example one. We already had example, so I'm just going to call it example one. Okay, so here I'm just going to import few things out from our main. One is app and another one is db. I'll tell you why I'm doing that. So I'm just going to check our home page. When you don't have any articles and nothing is inserted, home page should give you all articles but nothing inside it. So I'm just going to call test no articles home page or home, right? So here what I'm going to do, first I'm going to get the test client. Like I said you, the application Flask app should be able to give you test client. So you get that using client is equal to app.testClient. This is a very Flask way of getting a test client. You can send request to this test. Before we do that, we will create an app context and push the app context, right? Now for the app to start, we need to create the database, right? Actually, we have to set up a database. We have to be able to create all the tables in the database at least, because application will try to connect to database even if we don't have any data, right? So that can be done in SQL Alchemy way by db.createAll, right? This will create all the entities in the model. Like it will go to the model and create all these tables in a given database according to configuration. Now we'll come back to configuration later, right? And then I should be able to send a request to get. This is what I was saying. You can send a request using client. Now we are making a get request to the slash, which is home, right? And we can capture the output. Since our title of our home page will be all articles, if you remember, we can run it and check it. Like for example, I'll just open in a new tab. I'll just go to sh run local run, right? Okay. So if you see whether it has article or not, our home page will be have a title called all articles, and the title is also all articles, right? So and that's what we are going to check. So I'm going to stop this now and go back here, and I'm just going to clear this. Okay, so here what we have done until now is try to see whether the response has title as all articles. That's all, and that's all we are going to double check and assert, right, as part of the things. And once the testing is done, I want to remove the context and then clear the database, right? Now there's one more change that we need to make, because we don't want to use same local development config for our testing. We want to set up a new configuration for our testing for various reasons. One, I don't want to use a real database like a file-based database. I want to be able to create soon and delete as soon as everything is happened, test is completed. I want to be able to drop all and clear the database, which makes it easy if I use a memory database. And it's always better to have a different configuration for testing, right? So you can easily make it by copy pasting it, same thing, and changing some values, whichever you want to take. Let's say we want to call it testing config, right? Let's say we call it testing config, and I don't want to use this. I want to use a memory based database so that it's easy to clear and start, and it will get auto destroyed as soon as we restart the thing, right? And then I'm going to keep these things same. You can change them as well, and I'm going to add one more variable called WTF CSRF enabled is equal to false. By default, CSRF will be enabled for all form submissions, for our login, logout, etc. Here we are disabling it because we are auto testing it. So it's usually used to as a security measure. We enable the CSRF as a security measure. Here we're just disabling it for testing purpose. Now we have a testing config, but we have not enabled it, even though in our local testing we are setting it environment as testing. So we might have to make one more small change to enable it as testing when the environment is testing, right? So let's do that. Let's add that part, and then we should be able to run the test cases, right? So here I'm going to add another condition. If the environment is testing, so I'm just going to print some logs and started testing, but loading the testing config. Let me just import the testing config. Right now we are set up to run the testing. So what happens? It sets up the environment as testing. If the environment is testing, then it loads the testing config and then runs the Pytest. When it enables the testing config, it actually uses all these configuration items. You could use other items if you want. One important feature is we are disabling the CSRF, and the other one is we are using in-memory database instead of file-based database. Right. So now let's try and run it. Let's see if this example runs. Okay, we are here, sh local testing. Yeah, so it has run. No articles home page has been successful. For example, if I want it to fail, if I make it like that, so it fails. You can see it also prints out what you got versus what you're testing. So you can see that in the result, in the response, it's all articles, but we are trying it all articles, so hence it's failing. So I'm just going to go back and set it up and run. So like this, you've been able to actually write the test case in a very simple and easy way using what we call test client given by Flask, right? That makes it easier to write test cases and run it. Now another important feature of testing is ability to set up and clear the things. That's what we're doing here. Now any test case like this one example has 4 steps. The first step is arranging, second step is acting, third step is asserting, and last step is cleaning. All right, let me actually set up write them. This is called arrange, right, where we are arranging things that is required to do all the work that needs to be done for testing, right? We are actually creating the test client, creating the DB, etc. That's part of arrange. Now next is act. Act is where we are actually calling the function that needs to be tested. In our case, we are calling get / which is calling the home page, right? That is act. Then we are asserting. Asserting is where we are checking whether the response that we got is same as expected. What we are expecting is this, and this is the response, and we are asserting that they are same, right? That's assert. The last word is a cleanup, right? These are the 4 steps in any test case or any test flow, and we always do in that order, so that it's always important to clean up as well, because if you want to test another one, you don't want the result of this to affect the next test case, right? So this is the order of any test case, and you just have to remember this is how the flow goes, right? It's arrange, act, assert, and clean up, right? So now we have run one test case, we know what is the flow like, But is there a way to easily set up arranges? Now, for example, if I write another test case, right here, let's say another test case for feedback or something else. Do we have to do this every time? Whether is there a better way to do it? Pytest gives you a better way of doing it by a functionality called fixtures. Fixtures, in a way, in literal sense, is arrange and tear down for any function in the Pytest framework setup, right? Software test fixture sets up the system for software testing process by initializing it, and as well as then also involves clearing it up. Now, in Pytest fixtures, you use yield instead of return when you're setting it up, so that you can also clear after the testing is run, right? Like, let's write an example with fixtures so that it becomes easy to understand, right? Okay, let's write example 2. Same thing in example 2, right? Okay, let's save this. Test example 2, right? I'm going to copy paste the same thing and modify it. Okay, so what we are going to do is use the same organization or flow, but this time using something called fixtures. That is done by importing Pytest first and importing using fixture. Let's call a function called def client and make it a fixture, right? And within that, move all the arrange client part of only, because we want to separate let's say database part separately. Now we are done here. Now what I'm going to do is, instead of client returning this client, I'm just going to yield the client, which is where all our tests will run. And then once the testing is done, I'm just going to clean up, right? So this is arrange, this is where the action happens, and this is where cleanup happens. Okay, because this, the way it happens is, it will run this first. When it's yielded, it will run the test case, and then it will come back and continue to run and clean up the things. Similarly, I'm going to define another texture called initialize db. Right. Just going to copy paste to make it easy. Okay. This is initdb, create the database. Same thing, like let's remove this, what we had done in the previous one. Now db.create all has been moved here, and then yield db, and then cleanup db, which is drop all. So now remove the duplication, right? So only assert, either act and assert remain in this function. The setup and tear down or cleanup has been moved to the fixtures, right? Now to use this fixture inside our test, we have to just make it a parameter to our function. Once you make it a parameter to our function, it will just become a fixture. Now it just means I just have to get client here, and I just have to call init database here. That's it, they'll get run. So let's put some print statement just to make sure that it's running. Then I'll say setting up db. Okay, to actually print this, we have to set up a parameter as well, usually called -s. Otherwise it won't print any of the outputs of print, because Pytest usually avoids printing them. Here it captures the standard out and prints them together at the bottom. So that's done. So let's try and run now. right? It's giving some error. Let's see. Oh, it's just functionality error. Okay, sorry. Okay, clear. Okay, you can see that first it's calling setting up client, then setting up DB, and then passed, right? So it's calling this, then this. Now if you actually put another print here, okay, let's just print one statement here called running. Okay, now let's run this. So you can see here, setting up client, setting up DB, running, cleaning up DB, cleaning up client, then done. All right. So that's how it's done. That's why we use yield instead of return. If you return, it will return and it will never come back. Yield will yield for a while and then come back once it's done. So that's how you actually set up fixtures. Now going back to the definition of fixtures, fixtures in literal sense are each of the arrange steps in data. They are everything that test needs to do its thing, which is to act, right? So it sets up everything, it clears everything or cleans up everything so it can be cleaned up for the next run. So that's why fixtures are very important. Now, if you have multiple files of such things, you don't have to actually write fixtures in everything because it's again duplication of code, right? So you can actually write them at the module level and put it in a file called conftest, right? Conftest is actually a separate config file in which we put fixtures so that it can be used by multiple test cases in multiple modules or directories, right? So let's create that and use it from there instead of actually putting it in the same class, the same file rather. Right, I'm going to create a file called conftest at the test folder level so that it can be used by both modules. Right. So now I'm just going to paste the same thing inside conftest just to make it easy for all of us. Right, here it is. And then what I do is if I go here, I can remove this. Right. So that it uses directly from the conftest instead of from within the class. Now, if you don't pass the parameter, it won't get set up. So you have to pass this as fixtures as parameters, so it gets set up and called. Right, let's run it now. There you go, it's still running. Getting client is inside the conftest here, right? So its scope of this fixture is at the module level, so it gets used everywhere, right? So this way you can have a common fixtures that can be used across your test cases. Now let's go one more step. This is a simpler case where we don't have much logic, right? We want a logic test where we want to set up an article and then test whether the article has been generated and published on the home page. In the sense, we create an article into the database and see whether it gets appears on the home page. Okay, we'll just call the test case here as test check one article at the home page and then see how it works. I'm going to just explain here. First, we are going to create a user. You can see, I'm just going to import all the models. Right, I'm using article and article others. I'm creating a user, test user with the email, password, and making it active. saving it in the database. I'm create an article called my article, and it's with content my content, adding it to database. Again, I'm setting up the relation between article and author and saving it to database. Now if I go to home page, of course it will have the title as all articles, but there should be one ratings icon. Why one ratings icon? Because when you actually open the page, there will be at least one article published into the home page, or shown in the home page, and then it will at least show one rating icon. We could check for anything, if you have a distinct way of identifying how many articles are published, we can use any of those methods. In our template, if you go to our template and if you go to articles, you can see that for every article here, every article we create like an article like icon, and it has a class called here it's called like icon, right? And then we can check for the like icon. I've called it article, but it will be like icon, right? So here it should fail, and then I'll change it to like icon to see whether it passes, right? And let's mask this beautiful soup thing for now, and we can come back to that again. Okay, now let me run this. Okay, it's passing, and now we can see it's failing because ratings icon is not seen. I think we called it another icon called like icon, so I'm just going to change it to like icon instead of ratings icon. Okay, now it's passing because like icon is found. You can see here there is like icon in the output, which means there is at least one article, right? At least one like icon is found in the response data and the text like icon. But I am not happy with this, because what if it's returning 5? If it's a bug and it's returning 5, I want to actually see the count, right? For which we can use Beautiful Soup. Beautiful Soup is a package that you can use to parse HTML, right? So I'm going to import Beautiful Soup and HTML parser, pass the HTML content to it, and then I'm going to find all inside the soup the tag called I with a class called ratings.icon, right? But here it won't be ratings.icon, it will be like.icon, right? So this should return all the ratings or likes that is inside our HTML output. Basically it should return only one, because if you see our template, if it iterates over send, and if it's only one article, there will be only one like icon I tag, right? So which should return only one. So hence I'm actually asserting length of ratings is equal to 1, right? If I put 2, it will fail. Let's see first. Yeah, see, it's actually returning 1, which is the correct answer, right? Okay, see, it passed. Just going to remove the print so it's much more cleaner. Now we can go to any level. For example, you can even try to get the title of the article and compare it to this title to see whether that's valid. Is it returning the valid one? Let's try that. Let's go to template, see. Okay, it's username H2. It's one of the H2s, right? We can try to get an H2. I'm just going to do another soup. Just going to mask it for a second. Called headings, H2 headings. It's just H2. Okay, and then it doesn't have any class, so I'm not going to filter by any class. That's the only H2 whole instance used. There's nowhere H2 is used, so that's fine. So length of H2 headings will be 1 as well, right? Length of H2 headings will be 1 as well, and assert h2 heading of 0 because there will be only one, and the first one dot string content of it equal to this content. Let's see if that works. See, it works. Now if I make it like, space or one, it should fail. Yeah. So you can go to any level of testing and checking, right? You can go multiple checks in the same things and to assert everything that you want to assert, right? So this is the way you write, like, testing in HTML content, because if you really want to actually make sure that the content is present and it's visible to the end user. There are many other ways. This is one of the ways that you can do in Python. And now you can, instead of writing that tests separately, a separate function where each time it's set up and it's cleared, we could all put them into a class file, or make it into a class and put it as functions inside the class, so it can be run one after other in, like, top to bottom approach. So you can set up in one other and continue to do other things in the class, so that we don't have to call this client or init database fixtures every time. So it's just a easier way of organizing the test cases. If this is simpler and easier, you can just do this. If you have a very logical flow of, for example, first login, then test one article, then add another article and test again, add another article and test again, and you want to make them as different test cases, then you could put it inside a class and organize them, so that it becomes easier to write the flow and it kind of organized together, right? Now let's write one of such together, where we are going to test by author, right? Which is another page where we are going to test the by author listing of articles, where we need to log in to test. Without login, it will fail, right? So let's create another file called test by author for testing by author page, right? I'm going to just copy paste that thing. It's somewhat similar, where we are actually creating test without login first, and then we'll log in and test first. Okay, I'm going to remove this because we called it test without login. Okay, and then if what happens if we try to test user follow redirect to, it's going to fail. That's what I wanted to see. For example, I am created a user, then I've created an article, then I've created an author, author article. Then I'm trying to go by articles by test user. It goes to a different page, but it then goes to only login page, right? It doesn't go to actually articles by test user because we are not logged in, right? So since we're not logged in, it should go to login page. That's the test. If you're logged in, it will go to actually articles by test user page, right? Because you could go back to our controllers and see that articles by is actually login required, right? I'm just going to run local testing. Okay, so it's working fine, it's running, right? Now I'm going to remove this roles required because we are not inserting roles currently, just for this testing purpose. We could actually insert a roles as well and assign the roles to user. Basically create a role first, then add the role to user and then continue. I'm not going to do that, hence I just removed that part. Now you can continue the same flow, like I said, test with login, right? So I can just add the login part and test. Right. So I'm going to create a post request to /login and pass email and password. Once I log in, I go back to articles by test user and then check whether a logout is in the response data, because as you remember, let me just start the server. Once you log in, basically if you go to Tejas GN, articles by, it doesn't go, it goes to login page. That's what we were checking until now. Now if I do this possible, it goes to this page where we actually print out log, the name of the user, and then article. So we can test for all of these, whether this is showing up, this is showing up, this is showing up, right? It should actually show up. The format of the title will be author, articles. This is header. Title will be this. The first H1 should be author articles Tejas GN, right? We can check for this format too, right? But in our case, we'll check what is the username based on that username instead of Tejas GN, right? So let's say we do this. That will be test user, right? We are checking for logout, and since we are not giving any username, I think we are printing username only in the sidebar. We're printing the username. Yes, we are printing the username. So the username also should be present in the response data, right? Username test user should be there in the response data, right? Now let's run this. First this will run and then this will run. Correct? So that's why what I was talking, in case of test articles by author, which is a class, these functions run from top to bottom. Now if I mask this and run only this, it will fail because the first test case is not run, right? The first test case is not run, hence this will fail because it's dependent on that to set up all this, to check this. That's actually one of the negative things of having a class wise also, because test cases become dependent on each other. Sometimes it's better to keep them separate, as just as simple functions instead of combining them as part of a class, right? So these are your test, including login part. You could test many other things. You can even do the same counting of articles. If there were only one article instead of this author, it should show only one article, etc., etc. You can do many other conditions. You can check for tables if you are inserting a table, columns, and how many columns, how many rows, etc., etc. You can add as much logic as you want for testing. And now we have seen almost all kinds of test cases, right? We have done like get requests, post requests, we've done login, without login, inserting the things and checking it, etc., etc. Now you can write for any of the, you can write for guest. If you're, have a feedback or a like button, you can test for that, etc., etc. You can do all of that as different, files. And now one more thing that we want to do is check the coverage. That's why we install the coverage package. Now what we can do is we can go to our local testing. Instead of directly running Pytest, you can run it through coverage. That's done by calling coverage first and then passing the Pytest to that. All right, do that, which is calling coverage and passing Pytest to that. Right, and then I want to print the coverage report, not just analyze it, but also print the report. So now if I do Pytest, you can see that it shows me the coverage report, like how many statements are there, how much is covered, and how much is not covered. You can give the path to only application so that coverage is shown only for the application. You really don't have to check the coverage of test, because what's the point? Because we are not testing with test classes, we are testing only the application. So this is how our testing is done in Flask using Pytest and built-in, test client given by Flask, which makes it easy to test. That's all for today. Have a good day.